Good morning, my dear students. Welcome to the chemistry class. In previous class, we discussed about the hydrated substances. Okay, and today I will start from this anhydrous substance. Okay, now we will discuss this anhydrous substances. Now, what are anhydrous substances? From the name, we can easily understand there is no water. Okay, anhydrous means no water. Okay, so the salts or substances which do not have any water crystallization, okay, in loose chemical combination with this salt, they are called anhydrous substances like sodium chloride, potassium chloride, sodium nitrate, ammonium chloride, etc. Okay, now these anhydrous substances we can easily prepare from hydrated substance. Okay, if we apply heat to hydrated substance, it can produce anhydrous substance. Okay, like if you take sodium sulfate 10H2, that is global salt, if you apply heat, then what will happen? It will form some anhydrous Na2SO4. Okay, copper sulfate 5H2 blue vitriol. If you apply heat carefully, then it will form anhydrous CuSO4. Blue vitriol is blue in color, but when it is forming anhydrous CuSO4, that is white in color. Okay, so in this way you can prepare anhydrous substance. Next we will discuss these efflorescent substances. Now efflorescent substances, when you keep these hydrated salts or hydrated substances in air, okay, then what will happen? They will gradually lose the water of crystallization. They may lose completely, they may lose partially. Okay, and why this is happening? This is happening because inside the crystal the vapor pressure is higher compared to the atmospheric pressure. Okay, atmospheric vapor pressure. That is why they are losing the water crystallization. Okay, and these type of salts are called efflorescent substances, and this phenomenon is called efflorescence. Hope you can understand. Example we can give like blue vitriol CuSO4.5H2O, global salt Na2SO4.10H2O, green vitriol FeSO4.7H2O, like this. Next we will discuss deliquescent substances. Okay, now these are another substances, okay, which absorb moistures, okay, when exposed to air at room temperature and become liquid. From solid state it will become liquid. Okay, and this type of salts, okay, generally called deliquescent salts, and this phenomenon is called deliquescence. And why this is happening? In this case, what is happening inside the crystal? Okay, the vapor pressure or pressure is very less. But if you think about the air vapor pressure is very high. So definitely it will absorb. It has the tendency to absorb the moisture from the air, and what will happen? It will turn into liquid. Like caustic soda, sodium hydroxide. If you take ferric chloride, often when in the laboratory we open the ferric chloride bottle, okay, stored long time, and we will find some liquid ferric chloride. Why? Because it is absorbing moisture. Okay, that is why this type of compounds, okay, generally preserve in a desiccator. Okay, today I will discuss what is the function of desiccator and desiccating agents. Then you can easily understand. And this type of deliquescence properties, okay, we often observe in our kitchen during the rainy season. The table salt, okay, generally required for cooking purpose. Okay, in every food we are using this table salt, and this table salt, okay, in the rainy season become moist, and even sometimes we found that liquid, okay, liquid water, okay, inside that the container of the table salt. Why? Actually, sodium chloride is not the deliquescent substance. Whatever salt we are using, there is some impurity like magnesium chloride, calcium chloride. Okay, so these impurities are deliquescent. Okay, these impurities are deliquescent. They will absorb moisture, okay, from the air, okay, and become liquid. So whole sodium chloride will dissolve that water, okay, and turns liquid. But if you take the pure sodium chloride, then it will never dissolve, because there will be no magnesium chloride and calcium chloride. Okay, so like we can tell like that Tata salt, okay, almost pure sodium chloride. Okay, only iodine is added. Okay, so this type of salt I think will not turn into liquid during the addition. Next we will discuss another important substances, that is called hygroscopic substances. The salts which absorb moisture from air, but here there is no change of the state. It will not turn from solid to liquid. Okay, and this type of substances are called hygroscopic substances, and the phenomenon is called hygroscopy. Hope you can understand. And hygroscopic substances may be not only solid, there may be liquid hygroscopic substances are there. Example we can give that concentrated sulfuric acid, phosphorus pentoxide, calcium oxide, silica gel, and anhydrous calcium chloride, etc. Next we will discuss one very important thing, that is called drying agent, and another is dehydrating agent. So what is drying agent? Drying agents are substances that can readily absorb moistures from other substances without chemically reacting with them. Example we can give that anhydrous calcium chloride, anhydrous magnesium sulfate, anhydrous sodium sulfate. Okay, and they are also known as desiccating agent. Next we will discuss what is desiccator. Desiccator is an airtight vessel. Okay, it may be made of glass, it may be, now we are using that plastic. Okay, that means polymer, we are using polymer desiccator. Okay, and it is generally used for drying different types of chemical, and in desiccator we are generally keeping these desiccating substances like concentrated sulfuric acid, anhydrous calcium chloride, silica gel or quicklime. They will absorb moisture. Okay, and they will make the environmental inside the desiccator moisture free. And sometimes some chemicals, just now I told that ferric chloride, okay, ferrous sulfate, okay, these things we can preserve, okay, in a desiccator. Okay, and desiccator we can, here also one option is there, we can take the air inside out by using a vacuum, okay, or vacuum. Okay, now here whatever we have discussed, that this concentrated sulfuric acid, that anhydrous calcium chloride, okay, that phosphorus pentoxide, okay, quicklime, okay, they can be used, okay, as a desiccating agents. Okay, so we have to keep some substances if any moisture is present. Okay, and if your that substance will absorb that moisture. Okay, and in the different types of instrument, okay, very high cost instrument like infrared spectroscopy instrument, ultraviolet UV visible instrument, there we are using silica gels. Okay, that silica gels have some color. Okay, when it will absorb moistures, it will become deep blue. Okay, and actually maybe there may be copper sulfate is there, but again if we you can reuse this silica gel crystals. Okay, and again if we apply it, again it will become white. Okay, because they will lose that water molecule, again it will become white. So silica gels also is a very good desiccating agent. Next we will discuss dehydrating agents. Now what is dehydrating agents? Dehydrating agents are substances that can remove even the chemically combined water molecules, okay, from compounds. Okay, so whatever I am telling, that this is a chemical reaction. Okay, here dehydrating dehydrating agent is removing chemically water. Okay, suppose we can tell that if you take that copper sulfate, that means blue vitriol, dot 5H2, and if you add some concentrated H2SO4, what will happen? Definitely it will absorb the chemically combined water molecule from this blue vitriol, and it will form anhydrous copper sulfate. This is blue in color, and there will be elimination of 5 water molecule, and this will be anhydrous. Anhydrous, and its color will be white. Okay, another example we can give that in case of sucrose. Okay, sucrose formula is C12H22O11. So if we add concentrated sulfuric acid, there will be charring of sucrose. Okay, and you will get 12 carbon plus 11 water. So it will remove water, chemically. Okay, so here whatever we are observing, that a new compound is formed in this case. Okay, so these type of chemicals, okay, they are called dehydrating agent. Okay, now different types of gases are there. Okay, there we are using some drying agents like concentrated sulfuric acid, calcium oxide. Suppose your gas is HCl gas, so here we cannot use calcium oxide because HCl is acidic and calcium oxide is basic. But if you use concentrated sulfuric acid and if you pass the HCl, whatever moisture or water vapor is present in HCl gas, that will absorb by concentration. So here concentrated H2SO4 is acting as a what we can say, that drying agent. But here if you use that concentrated sulfuric acid in case of cane sugar, that will be the dehydrating agent. They will react chemically. Hope you can understand. Okay. Next, another we can think, like if we produce ammonia gas, okay, then how will you dry this ammonia gas? Here we cannot use concentrated sulfuric acid because ammonia is basic and sulfuric acid is acidic. So here we have to dry it by calcium oxide, that is quicklime. Hope you can understand. And sometimes during some reaction when we are working up, that means work up is done, then we have to add some water to remove the inorganic impurities. Then that organic liquid, okay, it may be ethyl acetate, it may be chloroform, it may be hexane, okay, or it may be ether, okay, that contains moisture. So liquids are dried by anhydrous sodium sulfate, anhydrous magnesium sulfate, anhydrous calcium chloride at room temperature, and after we have to keep it for some time, and after absorbing this sodium sulfate, that water present in that liquid, or magnesium sulfate water present in the liquid, okay, then we have to, what we have to do, we have to filter. We have to filter and to remove this hydrated sodium sulfate or magnesium sulfate. Then whatever liquid we will get, that will be almost dry liquid. So in this way we can dry the liquids, okay, by using this type of anhydrous sodium sulfate, anhydrous magnesium sulfate. Hope you can understand. Next one very important thing, questions generally comes from this, that already I have discussed. What is the difference between that drying agent and dehydrating agent? So again I am telling that drying agents remove moistures from other substances, but dehydrating agents, okay, remove chemically combined elements of water, okay, from the compound. Suppose HCl gas, okay, we are drying by using concentrated sulfuric acid. So here this concentrated sulfuric acid will just remove the moisture or just dissolve the moisture in it. But if we use concentrated sulfuric acid on cane sugar, then what will happen? It will chemically react and sugar molecules, okay, will turn into carbon, okay, that is called chain, okay, and there will be elimination of 11 water molecules. Hope you can understand. And drying agent, okay, whatever is happening here, this is a physical change. But in dehydrating agent, whatever it is happening, this is a chemical change. Actually, new compounds are forming, okay, and that is why this is the basic difference between the drying agent and dehydrating agent. Hope you can understand. Next, we will go to another new topic, that is soft water and hard water. Soft water and hard water. Now, what is soft and what is hard? First, you have to understand. Now, soft water is one type of water, okay, that readily produce leather with soap, okay, is called soft water. Okay, all of you have idea about that soap, okay, that it is a one type of carboxylic acid, salt of sodium of long alkyl chain, okay, having long alkyl chain, okay. If you take some distilled water, definitely if you add some soap, it will form that, what you can tell, leather or foam very easily. If you take rainwater, also it will form that foam or leather very easily. So this type of water we can tell these are soft water. So basically what we have to do, you have to take some soap and we have to add in water. If it is forming very quickly leather, definitely we can tell this is soft water. But if water, okay, does not readily produce, okay, the leather or foam, okay, with the soap solution, then we have to tell this is hard water. Like sea water containing huge amount of salt, river water, lake water, okay, these are one kind of hard water. Now hardness of water is due to what? Due to presence of some bicarbonate, chloride, sulfate, salt of calcium and magnesium. When water flows over beds of limestone or dolomite, limestone is calcium carbonate and dolomite is magnesium carbonate, then the carbon dioxide converts calcium and magnesium bicarbonate, okay, and make water hard. So what is happening? So calcium carbonate is reacting with carbon dioxide plus water, forming calcium bicarbonate. Okay, in the same way magnesium carbonate also react with carbon dioxide and water, forming magnesium bicarbonate. So when this calcium bicarbonate or magnesium bicarbonate will form, definitely what will happen, the water will become hard. Actually what is happening, when you are using some soap, that soap, okay, will precipitate this calcium and magnesium. Soap will react with this calcium magnesium and it will be precipitated. But whenever sodium salt is there, that will not precipitate, is soluble. But calcium, soap or calcium salt of soap or magnesium salt of soap, it will not form any leather, and leather it will be precipitated from that solution. Next we will discuss one very important thing that is given in your book, that is called stalagmites and stalactites. Stalactites. Okay. Now what is stalagmites? In some limestone caves, okay, the conical pillar of calcium carbonate which grows downwards from the roof, okay, is called stalactite, and one which grows upward from the floor is called stalagmite. Okay. So you can understand what is stalagmite and stalagmite. Suppose you think this is a cave, okay, inside the cave. So from the roof there is formation of pillar like this, conical pillar like this, okay. This is from the roof towards the downward. And another, at the base, there is also some calcium carbonate conical is forming, that is from ground floor. Okay. Now this type of formation, this one is called stalactite. Stalactite spelling is STALACITE, stalactites. Hope you can understand. And stalactites, TITES. And whatever it is forming in this ground state, this is called stalagmite. Hope you can understand. Okay. Actually what is happening, because of high pressure and there may be some warmth or heat, okay, inside the cave, and that will convert that calcium bicarbonate to calcium carbonate. Suppose that calcium bicarbonate, if you apply high pressure and heat, that will form calcium carbonate plus carbon dioxide plus water. Okay. So now this calcium carbonate, okay, will be precipitated, okay, and forming this type of conical shape, okay, inside the limestone cave. Hope you can understand. These are very important, and there will be formation of carbon dioxide and water. Okay. Next, we will discuss that hardness type. There is no softness type, but there is hardness type. Hardness may be two types. hard water may be two types. One is called temporary hard water, another is called permanent hard water. Now temporary hardness is due to the presence of calcium magnesium bicarbonate dissolves in the water. Okay. Now why it is called temporary? Because if we heat this calcium bicarbonate or magnesium bicarbonate, then it will decompose. There will be formation of calcium carbonate that will precipitate. Okay. And that is insoluble, and in case of magnesium bicarbonate, it will easily precipitate as magnesium carbonate. So in the solution there will be no calcium and magnesium ion. Then it can easily form the leather, okay, leather with this soap. So in this way we can easily, okay, remove the hardness simply by boiling of water. So this type of hardness is called temporary hardness of water. Now what is the permanent hardness of water? Permanent hardness of water is due to the presence of chlorides and sulfates of calcium and magnesium dissolved in water. It is permanent because you cannot remove this type of hardness simply by boiling. And permanent hardness of water can be removed by addition of some washing soda, and in higher level you will be able to understand. Another thing is there, that is zeolite. Zeolites are the microporous crystalline solid of aluminum silicate minerals. Okay, so now in your level you can use that washing soda. Okay, now washing soda formula is Na2CO3.NH2. So whenever you are adding sodium carbonate, suppose calcium chloride is present, you are adding sodium carbonate, what will happen? This calcium will precipitate as calcium carbonate. Okay, and there will be formation of NaCl. That is soluble in water, no problem. NaCl will not create any hardness, okay, but which one is creating hardness to the water? That is calcium ion. So calcium ion will dissipate as calcium carbonate. Hope you can understand. In the same way, if there is magnesium sulfate, that will also react with sodium carbonate and forming magnesium carbonate as precipitate, and there will be formation of sodium sulfate. Hope you can understand. So in this way we have completed, okay, the discussion of soft water and hard water and their types, and next day we will discuss what is the advantage and disadvantage of this hardness of water, and how to remove, okay, this hardness. There are different types of method is there, plaque method is there. Okay, next day we will discuss. So today up to this, thank you.